Okay, guys, so we're going to be looking at solving exponential logarithmic equations today. I've written some of the logs of laws that we looked at, or laws of logs, sorry, looked at before the break. We've got the addition law, where we're adding two logs to the same base, and then the subtraction law. And so in the addition, we just multiply the two numbers, and in the subtraction one, we just divide the two numbers. Just be careful not to divide the two logs from each other if you're using that law, because that would be incorrect. And then on the left-hand side here, we have the power law, which allows us to move the power in front of a log. And over at the far side, we have the change of base law that allows us to change bases when maybe the base isn't the best choice in the beginning. So you can go to base 10 if you want, or see base C, which means just any base you want to choose. And the very end, you can see ln there, which is log in base E, which might also be preferred depending on the type of question. So as we go through these questions, what I would encourage you to do is pause the video and then try to solve the question on your own. So the first equation, we have two logs and then a constant term. And generally there's two ways to go about solving these kind of questions. One is to get a log on each side of the equation of the same base. And if you can do that, then what you're saying is that the log of the value A is equal to the log of the value B. Now we don't divide by log here, but we can actually drop them or just get rid of the logs, and we can say that A now is equal to B. But it's really important to understand we're not dividing by log. The left-hand side is not loga, or log times A. We're not multiplying the G by the A there. So you can drop logs if you have one log on each side, or another option is that if you have the log of a number equals, let's say, a constant term like 2, and let's just say this base was 3 here, then you could change the log statement into an exponential statement. So the base being 3 and the power being 2, this would be 3 to the 2 is equal to A, which means A is equal to 9. So in our first example here, we can combine the two log terms, and that would be the log of 2 minus 2x multiplied by 1 minus x, see, 1 minus x, all equaling 5. So this is really the log of 2 minus 2x minus 2x plus 2x squared equaling 5. And our base of our log is still going to be base 2. So it looks like we're going to be using the second choice here. So we'll move this over. So this would be 2 to the power of 5 is equal to 2 minus 4x plus 2x all squared. All right, there we go. And so 2 to the 5 is 32, so we can move that over, and we would get 0 equals 2x squared minus 4x, and now we're doing 2 minus 32, so minus 30. And then if we divide everything by 2, we get a quadratic equation that is x squared minus 2x minus 15 is equal to 0, and that would be x minus 5, x plus 3 equals 0. So x would equal 5 and x would equal negative 3. Now, you might remember that we can't log just any old number. The log of a number, the number we take the log of, sorry, must be a positive number. So in the statement where we had 2 minus 2x, that actually has to be bigger than 0. So negative 2x must be bigger than 2, negative 2, which means x must be, and we divide by negative 2, we have to flip the sign here, less than 1. And the other statement being 1 minus x, that statement must also be bigger than 0. So if you rearrange that, you're going to get negative x is bigger than negative 1. And so you actually get the same statement that x must be less than 1. So we must reject the 5. It's too big. And the only answer here would be x equals negative 3. We move on to the next question. Once again, please pause the video and you can try this on your own. Okay, so I'm actually going to look at the restriction first this time. So I'll take the restriction. I always like to kind of know that beforehand. So I have x minus 2 must be bigger than 0, so x must be bigger than 2. And then we have the log base 4 of 2x, so x must be bigger than 0. So we have kind of two restrictions here, but really the one that says bigger than 2 overrides bigger than 0, so where values must be bigger than 2. Now, in this question, I actually have to move this 2 first before I can use the addition law. So I'm going to use my power law here. So this would be log base 4 of x squared plus log base 4 of x minus 2, and that would equal log base 4 of 8x. So I can combine those. There's these are just values of 1 here, so that's not a problem. Now I can combine the left-hand side, so I have log base 4 of x squared times x is x cubed, and then minus 2x squared, and that's all equal to log base 4 of 8x. Okay, so I can now drop my logs. I have one log on each side. And once again, I'm not dividing by log, I'm just dropping the two log terms. So I get x cubed minus 2x squared is equal to 8x. So let's say x cubed minus 2x squared minus 8x equals 0. So it's another polynomial here. So I'll factor out an x here. So we get x squared minus 2x minus 8. So that's pretty sweet. Gives us a nice, juicy, factorable quadratic. So we get x minus 4 and x plus 2. There we go. Okay, so our solutions for this would be x equals 0, x equals 4, and x equals negative 2. Now, from our restriction above, we can see that x must be bigger than 2, so we'd have to reject the 0, we'd have to reject the negative 2, and our only answer here would be x equals 4. So that probably makes you feel pretty good inside. There we go. Okay, so we're going to pause the video here, and that'll be the end of this video.